Wagwan everybody, it's your boy Mr. H again. Today we're back with some physics, and we have one of the common questions where some students find some difficulty. It's projectile motions. Now this can come in a variety of different ways. There are a multitude of ways to ask these kind of questions depending on what is given to you and what you have to find. So I'll be doing a couple of videos on this, and if you guys have any other questions or any other kind of examples you would like to solve, just leave them down in the comments and I'll solve them in the next video, all right? So we have a question here, which is a ball is thrown horizontally at a speed of 10 meters per second from a bridge 50 meters above a river. Ignoring air resistance, we have to find the following. Okay, so first of all, let's picture a diagram. That's what I feel like is the best thing. So it says it was thrown from a bridge. So let's just say this is the bridge, and it was thrown horizontally. Okay, so if it's thrown horizontally at 10 meters per second, that means there is no y component of the speed. The only component of speed we have added is on the x-axis, okay? And there's one rule which you have to know: if there are two forces acting perpendicular to each other, they do not act up, or they do not influence one another. So if something is in the x-axis, it does not affect the y-axis. If something is in the y-axis, it will not affect the x-axis. All right, so if we know it goes straight 10 meters per second, it goes from a bridge, and of course a bridge is at a height, okay? And we know that the bridge height is 50 meters above a river. So we know the height of the bridge is 50 meters right here. Okay, ignoring air resistance, the question asks how long would it take for the ball to reach the water. Okay, so this is a simple example of how much time will it take for it to just land or hit the ground. Okay, now when you're using vertical height, we have to use vertical speed as well. And what is the initial vertical speed? So if I say, so I like to use the notations v and u. So u here is equal to 0. That's your initial. I'm just going to write that down here so we don't forget. That's the initial. And I like to use v as my final. All right. So my u is my u, which is the initial vertical speed in the y-axis, is 0. My force of gravity always is 9.8 meters per second square. And we know the height, which is S, is going to be 50 meters. Now, one thing I like to do in these questions, write down whatever information I know and whatever information is given to me. So I extracted that the speed in the y direction is 0 in the beginning, and we extract at 9.8 meters per second square. So now the question asks how long will it take the ball to reach the water. So now what connects distance, acceleration, speed, and time? We have to memorize the equations of motion. So here it becomes S is equal to ut plus half at squared. Okay, so we know that u is 0, so the u and t term is you can just remove it. So S is going to be equal to 50 meters is going to be equal to half at squared. So half times 9.8 times t squared, which we have to find. Okay, and so just simplify this formula, become t squared would be equal to 50 over 4.9, and your time is going to be equal to 3.2 seconds. All right, so this is the time it takes. Let me just actually write that down properly. Take square root on both sides, therefore t is equal to 3.2 seconds. Okay, so this is how long the ball it'll take the ball to reach the water. Now, what also is this? It is also the total flight time of this ball, right? So let's find part B. What is the horizontal velocity of the ball just before it hits the water? Now, this is a very simple question, but some students get confused by it. So remember, like what I said in the beginning. Horizontal and vertical forces, or any two forces which are 90 degrees apart or which act at 9 degrees to one another, have no effect on each other. Gravity affects straight downwards on the ball, and the horizontal force in the beginning was 10 meters per second. There's no friction, there's no air resistance, so it will remain 10 meters per second all the way until it hits the ground. So for the answer for part B is simply going to be the velocity of the ball just before it hits the water. So v, or the final velocity, would be equal to 10 meters per second, and that's pretty much it. Part C asks, what is the vertical velocity of the ball just before it hits the water? So now we start with a vertical velocity of 0. We have to find the final, right? And we know acceleration is 9.8 meters per second square. We know our distance is 50 meters. We found the time in the previous question, which was 3.2 seconds. So now all this is given to you. You are free to choose whichever equation of motion you want. but I'll just use the simple ones. So I will use v is equal to u plus at, and here v is equal to u is 0, it gets canceled out. It'll be 9.8 meters per second squared multiplied by 3.2, which is going to be equal to 31.4 meters per second. Now, because this is a downward force, I will put a negative sign, because the what I like to imagine is upwards and towards the right are positive values, downwards and to the left are negative values. So the velocity is going to be negative 31.4 meters per second. This just indicates it's going down. Okay, so now we will go on to the last part, which is where the total velocity of the ball just before it hits the water. Now, what does this mean? We have to resolve the forces. So the total velocity of the ball is going to be what, because the ball is coming at an angle, but we know the horizontal and the vertical forces. Okay, so the horizontal force is going to be 10 meters per second. The vertical force, or the horizontal velocity is 10 meters per second, and the vertical velocity, which we just found just before it hits the water, is 31.4 meters per second. Now, if I just move this arrow over here, does that not look like a right angle triangle to you? So I have my adjacent, I have my opposite, and I just have to find my hypotenuse. You can just simply use the Pythagoras theorem. So here my velocity square, or for the ball, would be equal to 10 square plus 31.4 square. Let's put negative there. And this will be equal to 30. So V, just simple calculation of roughly 33 meters per second. Okay, so now we have found the velocity, but we have to find the angle as well, because what is velocity? It is magnitude plus direction. Okay, so we need to find this angle. So we have our opposite and we have our adjacent. And our opposite is 31.4. So I can say tan of theta from SOHCAHTOA is equal to 31.4 divided by 10. And so theta would be equal to tan inverse of 31.4 divided by 10, and it's going to be 72.3 degrees from the horizontal. So the way you will say this final answer is that the ball's final velocity is 33 meters per second at an angle of 72.3 below the horizontal, or from the horizontal. Okay, I hope this makes sense. If you have any other questions, please leave them down below, and I'll see you on the next one. Peace.